welcome back to my devlog on the road to making a standalone VR game. In this episode, I'll go over my experience with expanding my knowledge on Navmesh in Unity. A Navmesh is Unity's way of handling character movement or pathfinding by generating a simplified mesh in the scene that can be used by anything marked as a Nav Agent. Adding a Nav Agent component to a character model will allow it to dynamically move along the generated floor and navigate around any obstacle. Bullet Time Agent was my first real solo attempt at using Navmesh for characters. I skipped a lot of difficulties by designing all my characters to have no legs, which kept things simple for me. So for my next project, I'm introducing legs. Legs are complicated because now they have to match the Nav Agent movement speed and direction, or it'll look like the character is sliding and look more uncanny than a character without legs. So a big step for me was actually learning the common techniques for handling animation with Navmesh based movement. To do this, I needed a test subject to experiment on in this workshop. So, meet Bob.
What guy?
Bob.
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 How many times?
It's just some simple cubes thrown together in Unity to form a semblance of a character, since this is purely for testing Navmesh movement. So the first step was just to recap what I already knew, which is using Navmesh to move Bob from point A to point B. Easy stuff, and the process was the same as what I had done in my previous work. I wanted to create some basic animations now for Bob, where it's walking on the spot, in other words treadmill animations. In order to do that, I had to just readjust the hierarchy for the cubes that form Bob. So I made empty game objects to function as joints and just throw the cubes into them as child objects. And this way it behaves like a rigged character would without actual rigging. With the animations done, I went with a simple approach for my next test, which was having the walk animation play whenever the Nav Agent is moving, and then switching back to a standing idle animation once it's not moving. I added extra things in, like adding a timer when it reaches destination before it's allowed to pick a new one. So I think I had it set to like 4 seconds wait time before it picks a new destination here. And then I also added distance checks into the logic. So based on the distance from the destination, it'll either start running or walking. And these felt like nice milestones for me because these are things I generally couldn't do before. The simple method of using treadmill-styled animations with a nav movement has all the problems I mentioned before of the character sliding or animation being out of sync with the movement. So I looked at the next method I was aware of but had little experience with, root motion. Root motion is where the animation drives the speed, direction, distance of the Navmesh movement, so it's entirely controlled by the animation. On paper this sounds pretty cool, but it gets complicated really fast. Whilst it looks like root motion drives the character around, in reality the Nav Agent and the character is left behind, which means that more logic is required to keep the Nav Agent and the animated version of it synced up. Get it even a little off and it'll look glitchy as the character starts teleporting between different positions. It also introduces more complexity whenever a character reaches a destination as well. I'll admit, whilst root motion looked cool, especially with animations like attacks, I was dreading the idea of using it for movement, just because of the difficulty of implementing it without issues. So I was leaning more towards using the two tested methods together for different purposes. That was until I stumbled on one of the official Unity tutorials for a hybrid style. It blends some of the benefits from both the simple style and root motion without causing sync difficulty between the character and Nav Agent component. This works by giving the Nav Agent control of the direction and distance of its movement, but using the animation to drive only the speed of the movement. So I can now have a character limp every 2 steps in an animation, and that sort of pause as it limps will be synced up perfectly with the Navmesh movement, and it's handled automatically with a very simple setup. I felt like this was the method I preferred the most, so I kept experimenting with it more. I added more bobs to the scene as I ran around, and eventually I needed to recognize which bobs were doing significantly different things from the other bobs, so I introduced new haircuts for them. Over time this got out of control, and soon all the new bobs would have different faces, hair, hats, body sizes, and so on. Anyways, back to the Navmesh learning. Around this time I was also watching a lot of YouTube video essays discussing the AI systems in a lot of old games. While most of it was outside my knowledge comfort zone, I got a ton of inspiration from them. I'm just going to give a shout out to channels like AI and Games for teaching me so much of how games handle character logic. The vid on the AI behind the game Fear caught my interest on how it handled points of interest where enemy characters can ping for any points of interest in close proximity, such as optimal locations to take cover or, finding a health pack. They were then able to claim that point of interest for themselves, preventing other enemy characters from going to that point of interest. This inspired me to learn two different actions. The first was learning how to ping for points of interest. After some research, I came across the overlap sphere action that within a single frame detects colliders around it in a given range. This felt perfect to me, so I did some quick tests to have a character pick random destinations while pinging for points of interest in a given radius. This is already creating a ton of opportunities in my head for cool things I could do down the line. The second action I wanted to learn after having seen the Fear video was how to claim points of interest. This turned out to be super simple, which is moving a child object to a new parent object. This one felt important to my current Navmesh experiments, so I wanted to see if I could use this with my existing bobs that are already running around. So the first step was to create points of interest that would act as available destination points. These were all grouped under a parent object called free positions. If a destination point is inside this group, it can be used by any bob that looks for a new destination. Next, once a destination is selected, I move that destination point to a different group owned by that specific bob and trigger Nav Agent to start walking towards it. When that bob is ready for a new destination, it releases the destination point back into the original group so another bob can then use it. It worked perfectly. I could now have a crowd of bobs running around the same destination points but never using the same destination in use by another bob. Just seeing this in action was so cool to me. This is definitely something I'll want to utilize in future in combination with dynamic positions. I took this a little further and added an action to each position. So when a bob reaches a destination point, it can grab the action from that point of interest and use that action. In this case, I made this bob dance, have it wiggle its arms, or sit.
All around me are familiar faces, worn out.
I also revisited the sphere cast pinging to create a very early sound detection system where the player can trigger sound events at specific locations, which can alert the character during its next ping. This one is a very early proof of concept, but it's something I'd like to develop further in future to allow enemies to investigate a suspicious location based off a point of interest triggered by the player. This all marked the start of my deep dive into learning more actions and systems to help build better enemies from a logic perspective, which kind of confirmed that the kind of game that I wanted to make was definitely combat related. These devlogs are about 6 months behind my actual progress so that I keep my devlogs consistent in content amount. So I mean it when I say it, my bobs are a lot smarter than the ones you've seen in this video. Something to look forward to.
I will crush you!
Bullet Time Agent is coming to Steam and Meta Store later this year. Two of my close friends over at Sci-Fi Studios are handling the port to both pcvr and Quest. It'll also support desktop play as well. Please show some love and support by giving that game a wishlist on Steam. Link is in the description, and it'll help a lot with giving the game visibility as it gets close to launch.
Let us decide who is most worthy through battle.
Bob.
Bob.